If you refer to my previous videos, I have worked on this hybrid turbine. This is the Darrieus turbine, and inside we have the Savonius turbine. And the issue which I faced was that the turbine direction was reversed. So I want to show you that what I mean here is that if you take a look on the how the Darrieus turbine works, or even the similar turbine which is the horizontal turbine, and because these both turbines work on the lift principle, and while the Savonius turbine work on the drag principle. So you can see that even if this aerofoil is right now is facing the wind, so the wind direction or the absolute velocity is pointing definitely in this direction, and this will always be. And if we apply the principle of the velocity triangle, so the second vector would be the velocity of this turbine. And you can see that this turbine is right now this is minus omega r. Basically, if you just place a value, this will be pointing in this direction. So it's a minus omega r, and the resultant force is pointing on this in this direction. So the flow is pointing basically in this direction. And similarly for this aerofoil, the flow is pointing towards the but in any case, even if it's pointing from the back side, you can see here. So this is the VR which is here. So even it is pointing now in this way, in this direction, but in any case, the direction of this velocity vector is always in direction of this rotation direction. That is in which direction it is moving. But the case is different for the Savonius turbine, and it will be moving in the direction where the absolute velocity will be hitting on these buckets. So from here you can see that this turbine will always be moving from the leading edge. So trailing edge will be moving towards the leading edge. While here because the directly force of drag is applied on this surface. So on this surface we have the less drag, and here we have the high drag. So because of the differential of drag is pointing in this direction, so we have the more drag force. And therefore, if you take a look on the geometry, so what is the issue here is that this is my leading edge, and you can clearly see in this zoom picture, and the trailing edge is on this side, and we have the more thickness here. This is also clear from here. And so if the wind is hitting here, so this will move the Savonius turbine in this direction, and so the direction of rotation will be here. But this turbine should be moving in this way, because the leading edge will follow the trailing edge will follow the leading edge. It should be moving in this direction, not in this direction. So that's why, as I told you previously in the previous videos, that I changed the direction of this blade, and now it is corrected. And you can see that in the simulation we had these results. And based on these results, I have decided about so even if the direction of flow is from the positive direction, so even this aerofoil, and right now relative velocity vectors are plotted. So this is velocity vectors are coming from the trailing edge to the leading edge, and then also on this side. So not even any aerofoil is having the flow which should be logically be done as not over here. So even in this case, the flow is moving on this direction. So it means that the somehow direction was wrong, and now it is corrected. And now I am making the mesh of this geometry, and I applied some few sizes and created the tetra mesh using the octree method, and deleted the surface the volume mesh, and smoothen the surface mesh after applying the few loops. And then I created the Denali mesh on this surface mesh, and now the time is to create the prism mesh. And last time I also created the prism mesh of around 6 layers, 3 layers initially, and 3 layers after splitting them into the more layers, or maybe we can go with the 9 layers. And right now also I change the size on this surface from 0.02 to the 0.01. So now we have the more smoother mesh and more cells on the this surface, and also we have, as usual, we have refined the mesh on the trailing edge, and as well as on the leading edge. So I want to show you, this is the our leading edge, and now this turbine will be moving because this flow will hit over here. If you take a look from the positive direction, so the flow will hit on this blade and this blade will move, and so is the case with this blade. So this will also be moving in this direction instead of this direction. So now it's time to define first the prism parts where we want to create the prism layers. That is on the Darrieus turbine, which is outside in the orange color. Then on the Savonius turbine, also on these two shafts. These two shafts, one is in the green color, and second is inside this Savonius turbine, and I can show you also. This is the over here. So this is a shaft for the Savonius turbine. These are short for the Darrieus turbine. So in any case, they are not going to produce any torque here at all. So now it's time to define them again. Once check one more time, check them, and everything is all right. And now just go to the compute mesh from the mesh tab and click on the prism mesh, and this will create the 3 layers only. So I will split 3 layers into 9 layers, and then I will rearrange them so that we have the smoothened mesh, or maybe in the proper order, that is it is increasing from the lower sizes towards the wall and to higher size towards the tetra mesh in the domain. So I will just wait for this to be completed, and it will take some time, maybe 15-20 minutes, and after that I will come back. Okay, so now we have created these 3 prism layers, and if you want to check them, then right click on the mesh and click on the cut plane, and then click on the manage cut plane, and you can choose any direction in the axis on which you want to cut the plane, but in this case I would be cutting the plane on the y direction. And also display surfaces, and then from the mesh click on the plus sign, and then from volumes you can see now we have these volumes with us, and also we have created some pyramids as well. But anyhow, I will first check the mesh and especially the prism layers, and let's say I display them at 0.47, so it will be little on the downward side, but we will see the mesh properly on the geometry. Or you can even go, let's say, at the 0.55 and apply. Okay, this is okay, and you can see that we have these prism layers, and maybe on some locations where the angle is sharp, we are getting some pyramids, and this is not required here, this is not wanted here. So I would be getting rid of these pyramids, and frankly speaking, Fluent doesn't like these pyramids, but CFX does like the pyramids over the low quality prisms. So for the Fluent, if a solver is Fluent, then it should go for the low quality prisms over the high quality pyramids. And for that I would be going back, and from the volume mesh setting on the besides it we have the prism, and in the prism I would be adding, let's say this is 0.01, so I would be adding maybe 1 and 2 zeros, or maybe one more zero, so 0.401 or 10 power minus 5, and dismiss. Again I will be creating the tetra mesh, and even now you can delete this whole mesh, volume mesh. So there is no need of creating the octave mesh and then denale mesh. So it is already there, so I would be deleting the mesh, and now I would create the denale mesh first, and then I would be creating the prisms. I will not show the process again. So after creating these prisms, and I hope that with these settings there will be no pyramids in the mesh. And now you can see that we have created prism mesh, and there are no pyramids in the mesh. And also I can show you the mesh from inside, and making it for the y coordinate. and displaying the volume mesh as well. And also at the same time, I will display surfaces so that you can view the mesh from that at which location we are plotting the mesh. And for the fraction value, I would be putting 0.45. And now you can see these are prism layers over here. And one thing you can notice here is that the quality is bit low. Although with prism the quality matrix does not really give you the accurate information, but right now it's a 0.03. But as I go for the division of mesh, this prism layers into 9, I will start to get the lower quality. So it's a better idea to smooth the mesh at this moment. So I would be, let's say, try like 0.3, and I will freeze this penta and the chord element. So they should be frozen, and these are the basically the chord elements. Okay, you can just freeze them, and so we are basically applying this operation only on tetra mesh. So the tetras which are basically are on the surface of this geometry, and also tetrahedrons in the rest of domain except the prism layers. So I will wait for this process to complete. Okay, second time I will make them float so that the ICM CFD can display same on some proper location, but it will not smooth the prism layers. And my target is that it should be at least like a 0.1, not 0.03, but should be around 0.1. Okay, now it's a 0.18, and if you take a look on the prism layers and the rest of the mesh, you can see that how this look like. Okay, number of nodes are finer at the leading edge as compared to the rest of geometry. So now I will try with okay, so now I will split the prism layers into 3 for each. So 3 into 3 would be 9 layers. And now again I will check although the quality is still 0.18, but I would be checking the mesh from inside, and again we will be using the volume mesh and as well as the surface mesh. So display them, and also I would be making this plane maybe bit lower, so maybe 0.4 would be the good value. Okay, so now we are at the 0.4, and you can clearly see the number of layers are increased from 3 to the 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then again I will go back to the edit mesh, and from here we have the option to basically redistribute the prism layers, and this time I would be making the ratio like maybe 1.35, and I will try first and see if I can get although first layer height is good enough, but I want that it should be go more towards to the surface, and thereby increasing the closeness of the mesh, and so the first cell height should be reduced to some value which will be producing like a good value of y plus values. Okay, so the function of this command is just to move the prism layers in a such a way so that we have the in a prop they should be in the proper order, and they should be graded more towards the wall. So there will be the less size of the or height of the sail of prism layers towards the wall, and then more towards the rest of the mesh. So you can see that the how this will look like. So this seems good to me, and you can also check on the these layers of the on the Darrieus turbine. And also I can go with another view, and this time let's say I try with the constant x value or constant z value. So they both give you should give you the same type of the things here. So this time I would be using, let's say, constant x value, and this should give you the value exactly on the crossing the whole turbine from the middle. And now display volume mesh as well. And this is how mesh will look like from the inside. And same will be the case if you plot with the constant x plane or the middle x plane here. This is already there, so I will try with the middle z plane. So mesh should be going from the minus x to the plus x. And this time you can see the mesh on this geometry part, and now you can zoom it and you can see how these prisms layer will look like. So they are going around the every part on these plates, on the shafts, on the Darrieus turbine, on the Savonius turbine, their plates, and especially take a look on these small walls here. And now again I would be checking the mesh quality before I export the mesh, because might be we get some negative volumes, and that can be corrected with the smooth elements globally. So right now by luck we have the minimum quality at the 0.18. So now there's no need to basically improve this mesh further, but if you want to try, then you can again once more try this function, and let's see that what will happen with the mesh quality. And the good quality mesh with the refined mesh on the every location is very important for a good CFD. And now the quality is further enhanced to the 0.2, and this quality is more than enough for the CFD simulation for this case. And we already decided about the solver and the boundary condition. They are already set on the all parts. This is the wall condition. You can see on this turbine, and on the shaft for the Savonius turbine, this is the shaft for Savonius turbine which is inside, and this is the shaft for the Darrieus turbine which are in the yellow color. One on the top side and one on the bottom side. And then we have the three plates for the Savonius turbine, which are number 1 over here, and number 2 over here, and number 3 on the bottom side of the Savonius turbine. So every boundary condition is set. So now I would be outputting this mesh. So simply click on the output mesh. So first this will save the project, and then it will ask you about the ICM CFD unstructured mesh file or UNS file. So just click on the OK. You can see it is writing the UNS file, which is basically is an unstructured mesh file for the ICM CFD. and click on open. And I will be putting name for the, because by default it will put the name for the mesh file as a fluent, so I will be putting name as a inner. So the full name would be inner.msh file, and click on done. Because the same name file already exists in the same folder, so it will ask you about permission to override. So grant the permission, because I want to replace the old mesh file with a new mesh file with the improved mesh sizing, with the improved prism layers. And also the important thing was to change direction of these turbines. As I told you earlier in this video, that the one turbine was moving in the wrong direction, which was basically this Darrieus turbine. But since we cannot reverse the direction of this turbine, so basically we reverse the direction of this Savonius turbine, and now they would be rotating in the counterclockwise direction, that is the positive y direction in this scenario. So as soon as the mesh is exported, you can read it again, and this will be done in the next video, that I will read these two mesh files, so you will see that how to read the two domains and how to create the interfaces and the bounding conditions.